Welcome. So in today's video, I'm going to be taking you through the process of pilecap. That's the process of constructing pilecap from start to finish. So this video covers from after the pile. The pile casting and digging is not part of this video. So we start from the process of doing the pilecap from the setting out, the blinding, down to the casting, the curing. So in this video, I'm going to be showing you the practical process of doing a reinforced concrete pipe cap. Now, the reason why I said it's a practical process is because some of us might know how to do pipe cap, we might have heard of it before, but in this video, I'm going to show you the practical way of doing it. It's a video, right? But yeah, it's going to be closer and well explained. So at the end of this video, just like I do see, if you find the video interesting, you can give me a like, and at the end of this video you can give me a like if you find the video interesting. So it's going to encourage me to do more practical video and more construction video. So let's dive into the video and start. Just like I said, that this video is pie cap work and the process of constructing a pie cap from start to finish. So let's dive into it and start the work for today. So the content of this video, it involves excavation and breaking of pipe, setting out, that is marking out of the building wall, blinding, arrangement of pipe cap with bars, formwork, positioning of starter bars, checking and cross-checking, concrete casting of pipe cap, formwork, striking, backfilling, and concrete curing. So I'm going to take you all through all this process. And these are the process that a pipe camp construction entails. So I'm going to take you through this process, and I'm going to be giving you a practical explanation on it. So let's begin. So the first thing is the setting out, and the setting out starts when after constructing the pile. So after the pile has been done, so the first thing we do is the setting out. That is from the drawing your the mark already in it, don't just like the normal setting out where you set out the wall of a building where you can excavate and begin to do your blinding and your no and your normal work. So in pile also it also involves setting out where you set out your point, know where your column starter and your wall is going to start from and where it's going to end. So just like the drawing you are seeing here, so you are going to take a look at the drawing and you offset everything on this profile board there. So that is setting out and marking out of building wall. So you mark all this out, and this is one of the crucial job in every construction process. Setting out is one of the first work we do after site clearing, and but in this process after the pile now, setting out is one of the thing you also do that you don't neglect. And if you are doing setting out, one thing you must know that if your dimension is 1550, most of the time some people will neglect the 50 behind the number. They will just take 1500, and some people, when you have 1505, some people will neglect the 05 and use 15. Now if you are doing this, it means you are either shortening the length of the building or you are increasing the length of the building. Increasing mean if you have 1505, you might say, okay, let me take 1510. No, you must be precise in your measurement if you are using the local method to do your setting out. Some people use total station, which make it easier for them to do setting out. So whenever you are doing setting out, make sure that you are precise with the distance. Now if I zoom this down, you might not see it when I zoom in, but let me try doing it. Okay, there are some dimension here, you can't see it because it is small. So the dimension, you must be precise in the dimension on the setting. So you just mark it around. So you are going to mark your building wall is going to be marked out during your setting out. So that is what the setting out entails, and is one of the jobs that you must do with cautiousness and care. Not be marking out the wrong point. So setting out is very crucial in every construction work, especially also in pipe cap. It is very important. Now the next thing we do again is the excavation. Now excavation involves digging the area where you need to do your pipe cap. You dig to allow for blinding and your pipe cap. most of the time when we do excavation, uh, when we do, people just excavate. You don't excavate just the. Let me assume in your drawing you have your pie cap to be 750 by 750. Now, if you are digging, you don't dig 750. You understand? You don't dig 750. You dig and leave allowance for the formwork and for the laborers or workers that are going to work around the pipe cap. So you leave a space like probably 300 to 500 for them to be able, as allowance for them to be able to work. Look at the picture here. Now this is the these are the pies. This is four pie. Now you want to do a single pie cap on this one. So there will be a space left out here, so they will be able to work on it. So that is and in uh excavation, because I call it excavation and breaking. If you check the content of this video, excavation and breaking. Now, how do you know what you are supposed to break in Pilecap? How do you know that you are supposed to break a particular line? Because we don't just break. Because those people that do pile, what they will do is they will cast to the natural ground level that they met on the site. That's what they are going to do. They are going to cast your pile and they will take their zero level from the natural ground level, except if you have a bench bank on the site. Even if you have a bench bank, they are going to cast starting from, they are going to use the natural ground level as their point zero and they will cast downward. Now, when you want to do your pile cap, how do you know where to dig, excavate to, and where to break to? Now, from this sketch, I'm going to be explaining how and to what depth you are going to be breaking. Now, this is just a sketch that I just drew out now. From this sketch, this is the natural ground level, and this is the GF is the ground floor. Let's assume this is the ground floor. This is the natural ground level. So this drawing is telling us that the ground floor, that is the DPC of the ground floor, is 500 higher than the natural ground level. Let's say you get to a site, this is your natural ground level, and you are being told from the architecture drawing, because you won't get this in the structural drawing. You are being told in the architecture drawing that this is your natural ground level or your road level, any point you have, and this is your building. Your building is 500 higher than the natural ground level. Then you go to your drawing. From this drawing, my beam is 900 Let me zoom in so you can see. My beam is 900 and my pie cap, I already know my cap. Let's assume my pie cap is 1 meter, and just like normal process, if this is 900, then the beam is going to be embedded in the pie at the dimension of 200 so it's going to enter by 200. So when you are casting this, you cast to this point where you leave 200 at the top, then you insert the beam at the point. So if this is 900 and I know 200 will be here, so it means the remaining length here is 700 and this is 1 meter, meaning this is 1.7 from the bottom of the pie cap to the top of the beam. Yes, this is going to be the same level as that of the slab. Now this is 1.7 meter. This is the top of the pie cap. So what do I need to do from here? I want to know the length to which I'm going to dig, and I know that from the bottom of my pie cap to the top of my beam is 1.7 from this drawing. 1.7. So what do? I know that this top here is going to flush with this top here, and I have 1.7. Now 1.7 minus 500, this is the natural ground level. This is where the pile is currently. So 1.7 minus 500, I'm going to have 1.2. It means I'm going to excavate and break for the next 1.2 meter. So anyway, I dig to, that will be the bottom of my pie cap and the top of my pie. I don't know if you watch this video again and repeat it, you are going to understand what I just explained. I got it from here. This is 1.7 minus 500. This can be any dimension. I'm just using this as an instance. Now you're going to dig 1.2 meter. Now when you dig 1.2 meter and you construct your pie cap from 1.2, you are going to have 200 left, and you know that your beam is going to be in here by 200. Now remaining 700. Now 200 plus 700, you are going to have your value. So that's how to know to what depth you are going to break your pie and your and excavate too. That's the depth you are going to excavate them. So the excess reinforcement, you can just trim them, trim them off and let them remain like 500 mm upward from the pipe. You are going to have your remaining iron with 500 mm. So that's how to know to what depth you are going to excavate and break. And all these things I just explain, you are going to get the level with the leveling instrument. Probably you have a benchmark. So I just assume this is going to be the benchmark, the natural ground level. You might have any level from the architectural drawing that this is the level you must use. And what you are going to do is just teach you how to know where you are going to excavate to. So this might be 1 meter. You might be told that your DPC is 1 meter higher than the road level. And you know this is 1.7. So 1.7 minus 1 meter, you're going to have 200. It means you are going to just excavate for 200, do your pie cap and your beam. Then you are going to have up to 1 meter. And sometimes the reason why we bury our pie cap in the ground is to avoid it being seen after the construction. So that's the process of doing the of excavation and breaking. So the next process is blindly after excavation. Look at this that has been excavated according to after the level it has been excavated. So you do your blinding. Now the essence of this blinding is to prevent the reinforcement from touching the ground, from starting from the ground, because on the normal way we do it, reinforcement does not touch the ground, it does not start from the ground. So you have to do your blinding where reinforcement is going to sit on. That's the portion. The blinding is not a structural member that you must pay much attention to, but there must be blinding on the floor, probably 50 mm. That's the attention you must pay to it. Blind when you are doing anything in the foundation level, your cover is always 50 mm, and the blind is going to provide a cover to this enforcement. So you must provide a cover of 50 mm. That is the blinding. And the rebar work is a very crucial aspect in this job that will pay much attention to the rebar work and the casting. They are very crucial that we pay much attention to it. Because we are dealing with reinforced concrete. So the major element here is the rebar work and concrete. So this is a crucial aspect you must pay attention to, and everything you are going to be doing will be from the structural drawing. You are going to pay much attention to the structural drawing. Now this is the structural drawing, and this is what we have after doing this. This is the plan and this is the section. This is another plan for the bigger pipe, and this is the section. So and this one. So let me show you more video on it. This is when it was being constructed, and I'm going to show you how it is being constructed from the drawing and how to read the drawing, the rebar drawing. And this is it when it was being formed. This is it. And let me show you how to see this drawing. Then this is the drawing I'll be using, because this is the one for the bigger one. uh, Let me have it like this. Let me have it like this. Now, let's pay attention to this one. This is the, okay, this is a section. This is a section showing the depth of the pipe. Now, a pipe cap like that. Now, this is the depth. Now, this is the plan. The section is when you are looking from the side, and the plan is when you are looking from the top. Now, when you are looking from the top, look at what I have here. This, I have a straight bar here. You can see it. I have a straight bar here, and I have a dot. The dot is showing me that the description of this bar. Now this bar is towards the long length, right? So it's telling me that I must have 5 by 20 and 5 by 16 at the longer section. Now, if you look at it here, at the longer section, I have 1, 2, 3, 4, 5. Now it's at the top and it's at the bottom. Can you see it? It's at the top, because that is what the drawing tells me to do. From here, it's at the top and at the bottom. Then I have another one that is distributing. Okay, they call that one B1 and T1. So I have another one that is distributing it. If you look at the drawing, you see this bar I'm touching. So, and the description says 9Y12 is going to cross this one I just arranged. So look at it. If you can't Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. 9, 1, 12 is going to cross this. Look at it, it's crossing, and it has another one because it is at the bottom and at the top. These are the distribution bar on this one are the main bar. This one are the main bar. In this instance, they are the main, and this are the one that are distributing it. This U are the one that are distributing it. You see, that's how it is being arranged. Then I have another one here, which is this U sidebar. It is also called bus bar. And we have it to be um, 2 by 2 Y12, 2 by 2 Y12. Okay, it is not here, it is in the next drawing after completing it. This is it. This is the bus bar. Are you saying it is a bus bar? And the function of the bus bar is to hold the two together. So in case there is excess load on this, so this enforcement will not be shifting, will not burst, the cage will not burst. Now this is the pie cap enforcement. It is arranged in form of cage. And just the way, just like what I've said, you must pay a lot of attention to that. Now, the next thing is the formwork. Formwork is any material that gives shape to the concrete. That you're going to have it around the pie cap. Let it give the pie cap the shape you want to cast. So this is the complete work here. It was braced. You must make sure it is braced very well. So when you cast, it will not be shifting. You are casting about 800 mm. The depth you are casting about 800, and that the weight is very heavy and can move this ball backwards. So you do it in a such a way that you are going to brace it very well, that this will not be moving backwards. So that is the formwork. The formwork, you can look at it from this video. So after arranging the reinforcement, what is the formwork? You see, while we are even doing everything, the line are still there. We didn't move the line we do from the second, we didn't move it. And we did that in order to get that, so you're going to know where to place your pie cap and everything. You see the line is still there. So you make sure it is at the center line. At the center line. Although some pile is going to shift, it's going to shift. So the next stage is positioning of your starter bar after your formwork. The next stage is positioning starter bar, and this is one of the crucial job in pie cap, in pie cap casting. So before you cast a pie cap, you must introduce the starter bar. The starter bar is this bar for the column that you are going to lap the column reinforcement to. So in order to know what length to cut, because you must know the adequate length to cut, because if you cut the wrong length, it's going to be a problem after casting the beam, because it's going to be short at the top. So let me read this note here. The length of the starter bar is determined from the drawing with the condition on site. Just like I said, the condition on site, if the site is asking you to go to a benchmark and you have a benchmark on the site that you need to meet up with, and the condition from the drawing. So the length of the bar is given as the bend. Now this is the bend. This bend is always 300, 200, depending on the person that is doing it. Let's say 300 plus the depth of the pie cap. It's starting from the bottom of the pie cap. This starter bar is starting from the bottom of the pie cap. So you have a bend which is 300 plus the depth of the pie cap in this case, which is 1 meter, plus depth of beam in this case, 900 minus 200, that is 700. That's you have 300 1 meter, 700, plus the lap length after the slap. The lap length depends on the reinforcement you are using. If it is 20 mm, the lap length is 1 meter. If it is 16 mm, the lap length is 800. So let's say you are using a 16 mm reinforcement for this in this condition. We are using a 16 mm reinforcement. So this is going to be 300 plus 1 meter, which is 1.3, plus 700, which is 2 meter. And let's say we are using 16 mm, that is 800 plus 8, the 2 meter plus 800, making 2.8. So this is going to be 2.8. Let's say it is 20 mm, it's going to be 3 meter. You understand it? That's 300, 1 meter, 700, making 2 meter plus 1000. That is 3 meter. You are going to cut this to be 3 meter, and you are going to bend 300 out. That is how to. Now look at the data bars. From mere looking at it, anybody that just come here and looking at it, we think this is too long. You understand? But we are doing the work. We know it is not too long. And if you can see, there is still a line there. It is a line we use in positioning it. So you are going to use the line to position it. The line. This is the center line. We pick it from the center line of from the setting out. So this is the center line. We make sure it pass. You're going to make sure it pass through the center of this pipe. And how do you know it pass through the center? This it is from your drawing. It is from your drawing. You are going to know if it passed through the center. Now looking at this is the pie now. This is the pie. So this is the placement. Just like I said, it's going to be 300 if you look at it now. Let me zoom in. If you are seeing the bend, look at the bend. This is 300. If you are seeing it, plus depth of this 1 meter. So let's say 1 meter, we get to this top, plus the beam 700. We are going to have the remaining 1 meter. So that's that to do the syllabus. So it is one crucial job that you must pay attention. So after that, the next thing is checking and verification. So I can say checking and cross-checking. Now, the reason why you check is to ensure there is no error in the work you have done. When you are even doing that, you are certain what you are doing is wrong, is always try to call your superior to come and check what you have done. So the lap length must be observed. The type of enforcement specified must be observed. The strength, the tensile strength of the enforcement must be observed before you cast. Because after casting, you are going to embed all this in the casting. After casting, you now realize you have made a mistake. Now, those mistakes, before you can recover them, it means you need to break the casting. And breaking the casting after you've used some amount of cement is not will not be economical, will not be economical at all. So you do checks and make sure everything is right, make sure the positioning of the starter bar is right from the when you check from the drawing that everything is right, make sure the arrangement of your reinforcement is right, make sure the size of your pie cap is according to the drawing, and every other checks you need to do, every other checks you need to do. Then after that, you can now go to the next one, which is casting of the pilecap. Now this is it. And while doing this, you must ensure that the mix the mix from the drawing is being observed, the appropriate mix. Most of the time when we cast pilecap, it's always the grade is always 25 newton per millimeter square. That is the grade after 28 days. It's going to be 25 because it is a foundation work. Remember the Bible verse that says, if the foundation could be destroyed, what would the righteous do? So whenever you are doing a work on foundation, it is a time to pay crucial attention. It is not a time to compromise. Because if you compromise in fact, if you are doing any work, it is not a work. They say what is worth doing is worth doing well. If you think it is worth building a house, you think it is worth building a 5 story, then do it well. Because if you don't do it well, at the end, everything will crumble and turn to rubble. And that is a waste of a lot of money. Enforcement in the market now is very expensive. Even buying of cement and every construction material now is very expensive. So it is a time to pay crucial attention to whatsoever you are doing. So I was talking about the missing. You must make sure that the missing is according to what you have in your drawing. No, you must not compromise in the mixing. Now, the note I have there, ensure the right mixing proportion is used and back up well vibrated. The surface of the casting should be made rough for a proper binding with the subsequent casting. So you can see the surface that it is not smooth. It's not so it is not the work that you need a bricklayer on. It is not smooth. And the reason why it is not smooth is so that when you are casting your beam and you are completing this, the reason why we left this is because from what I said from the beginning of the video, your beam is going to anchor here. You understand? It's going to anchor here. So because it's going to anchor, you must leave this place open. And when you are doing your beam, then you put a board around it and cast it. So for the next casting to bind with this successfully, this area must be rough. It must be rough, and your casting should be well vibrated. Look at it. This is after the casting. This is the process of the vibration. It must be well vibrated. It must be well vibrated. Content also. Okay, let me share a brief the water content. The water, some of the time we have a water content of 0.3 in concrete, 0.35. Some of them we have 0.45 and 0.55. The more you water, the weaker concrete in sometimes, if the water is more, it's going to cause blinding. That will lead to blinding. And if the concrete is the water is not is too small, workability of the reduced. So one of the percentage of water I do advise people to use is 0.45. You can look at this during the process of vibrating. You can see it's not that watery. It's not that watery. Look at the look side of the formwork. It's not that watery. So the water content we use is 0.45. Now, how do you know water content by casting? The water content is whatever you want to use multiply by the weight of uh, of concrete and by the weight of cement rather. Now let's say you are using one bag of cement to one sand to do uh, granite, just for instance. Now what's the weight of that cement? It is 50 kg, right? Now 50 kg multiplied by 0.45, then you are going to have your answer in kg. Now if you have your answer in kg, then you now convert from kg to liter. Convert from kg to liter. Now, density is mass over volume. Density is mass over volume. Now, you have the mass and you are looking for the volume, right? Density of water is 1000 gram per meter cube, if I'm right. Gram per meter cube. Okay, 1000 kilogram per meter cube, rather. 1000 kilogram per meter cube. That is going to be what you have from 0.45 multiplied by 50 divided by 1000. Then you are going to have the water content in volume. And you can also convert from volume to liters. That is 1000 liter is one volume. Maybe I'm going to do this in another video for better understanding. So I'm just trying to say the water content should be 0.45 times the weight of the cement you are using per mix. So that's how to get the water content. Look at this now. Water content is no much. I did bring the water content is much. We have been seeing water here during vibration, but because the water content is minimal, so we don't have our cement being washed away in the water. We don't have bleeding. So that is that about that. Then the next stage is formwork striking. You remove the formwork after 24 hours, after 12 hours, you can remove the formwork and backfill. Look at it. Even before removing some of the formwork, you've been already curing already. You can see it already curing. So after removing the formwork, the next stage is backfilling. And I see backfilling as one form of curing. And curing, we do curing to make sure that the water content in the concrete does not dry fast. Just like the kind of weather we have in Africa is a very sunny weather. So that's one of the reasons why we must take curing very serious. We must take our curing very serious because when the water in the concrete is drying too fast, it can lead to crack in the concrete and thereby reduce the strength of the concrete. Now, when you don't allow it to dry quickly by curing, then you are going to have a concrete with the required strength. So after the next day, we just backfill. So you're going to backfill around the backfill is going to prevent it from drying quickly. Then you can go ahead with your cure. Now this is the process where it is being backfilled. You see, and after that you do your curing, you can say it has been backfilled. So this area will be protected and water will not dry fast. Then we still pour more on it to keep it wet. Keep it wet. Now, in a normal condition, we cure for 28 days. The curing of concrete is for 28 days, and we take the cube to the lab. We do a cube and take it to the lab, cure for 7 days and some 28 days. No, it is normal. It is normal that concrete will get 70% of its strength in 7 days. So you must take it to the lab and make sure you have 20 you have 70% of the strength you casted and cure it. So this is the last stage of the pilecap work, the process where you cure and cure for 20, but that doesn't mean you not continue with the subsequent work. You still continue with the subsequent work you will have to do, but you must keep curing the concrete. So you must keep curing this. Another place where we cure, you must keep curing. Now, another thing is preparation of cube for testing. Just like I mentioned recently, you cure for 28 days, and you test for, some people test for 7 days, 14 days, 21 and 20. But normally it is what most people do is for the first 7 days and the first 28 days you prepare your cube and take it to the lab to cross, to make sure that the design strength is what you have. What people do in advanced country is that they do the cube test and they take it to the lab, they test before knowing what to do on site. This is what I'm trying to explain. Let's say in your design, your design passed with 25 grade of concrete. That is the mix ratio of 25 make your design to pass. And before doing that, probably you are in a new environment, you need to get the sharp sand, you need to get the granite. You mix it at a proportion you think will give you the grade of 25. Let's say in this instance, 1.5, 3. And after 7 days, you take it to the lab. After 20 days, you take it to the lab, and you have 25, grade 25. That is when you can come to the site and use that same sharp sand and that same granite to do the work. But what we do in this part of the world, we cast, and after the casting, that is when we now take part of it, cure for 7 days and 20 days, then take it and then take it to the lab for for testing, which is okay. And so in summary, so all what I've just said in summary, always ensure the right process are followed in order to get the best result. Also note that the tensile strength of the rebar should be checked to ascertain if the rod meets required design and design specification. Strength of rod used is always 40 newton per millimeter or 460 newton per millimeter square. Now, what I'm trying to say in this is the rod we use in construction, we test for it. Probably when you are doing a work that is going as high as maybe even any work, I can say 1 story, 2 story. When you remember that what you are doing involves life and money and fun, so you need to take the necessary step you need to take. And probably in your design, you might have most of the design we have our the strength of the enforcement to be 410 or 460. So what I'm trying to say is you should make sure that your reinforcement meets the required strength. If you are to construct with a 410 newton per millimeter reinforcement, and the reinforcement you bought because you didn't test it is around 350, you already do, without being told, you are jeopardizing the safety of the structure already. You are jeopardizing the safety of the structure. So you must test for reinforcement, which is what I just explained in this first one. Now, the second one is about the concrete. If you must follow the concrete design mix. So, if the design mix from the drawing say it is grade 20, it is grade 25, that is what you must use because it has been modeled and been designed before you construct. So, if you are not following that grade, probably you are doing a lesser grade because you think it will work. So, it means you are jeopardizing the safety, you are jeopardizing the building already, jeopardizing the building. And another thing to take note of is the water used. Water used should be free of salt and other impurities. Water we use in construction must be free of salt. Now, the reason why it must be free of salt is because salt corrode iron. So when you mix with a salty water, it's going to corrode the enforcement. That is going to be making the enforcement weak in strength. Probably you construct with 410 newton per mm² enforcement. Now, when you use the salt water, it will reduce that strength because it will be corroding the iron. So salt water is not advised while you are casting your concrete. You are not even your enforcement is not even allowed to come close to water, even if it is not a salty water. Your enforcement is not allowed to come close because water is going to corrode enforcement. It corrode high yield enforcement. So another thing to take note of, the concrete cover should be provided to the pilecap. So concrete cover should be provided to whatever enforcement you are doing. Must provide concrete cover. The reason why we provide concrete cover is to make sure that the enforcement is not exposed to the atmosphere, because water, just like I just said, can corrode it, and fire also. When the reinforcement is prone to fire, it will weaken the strength of the reinforcement and jeopardize the safety of the structure. So the excess white is embedded in concrete is to make sure that it is not in the presence of fire and water. So the reinforcement will be inside and the concrete will appear outside. So this at the process of constructing the pilecap. I've just taken you through the process, and I hope the video will be useful for you. So if you find this video interesting, you can give me a like. So, and by doing that, you are encouraging me to do more videos on this practicable construction. Thank you for listening.